I'm going to end the week with our most elaborate world program yet. What we saw earlier was that cats have a mind of their own. When they get to the edge of the box, they just keep walking off the screen. Cows, on the other hand, cows are a docile creature. When they get to the fence, they turn around and they go back the other way. So we're going to do a cow animation now. And you can kind of see the key way it's going to be different, right? A cat only has a position. It always goes the same direction. But a cow has two changing properties, its position and its direction. So this is going to be a compound data problem. It's going to be a how to design worlds problem with compound data. This is a long video. You may not want to watch it all at one sitting. But a world problem is a long problem, and compound data makes it a bit longer. And there's a couple other interesting points that happen here along the way. So I would encourage you to be sure to watch this whole video through. Again, a good thing to do might be to stop it every now and then and try to work a bit of it on your own, getting ahead of the video. But don't do that when you get to the render cow function, because there's a special thing going on there that we need to talk about. What I have open here in Dr. Racket is the starter file. We're also providing intermediate solutions at different points along the way of developing the whole solution. And as I said, I'll be dropping into different places in this as we go. So here's the problem statement, worked out in a bit more detail. We're going to have a cow that walks back and forth across the screen, and when it gets to the edge, it changes direction and goes back the other way. And we're giving you a couple nice images of cows, which we got from Brown. Of course, with any world program, the first step is to do an analysis. I have the analysis already worked out, and here it is, and mostly it's like the analysis for the cat program. A lot of the constant information is the same, the width, the height, the center Y, the background. One difference is here the cow has two images, the image where it's facing to the right and the image where it's facing to the left. So that's one difference. The most important difference is reflected in the center picture and also in the changing information, which is that here there are two changing information values associated with a cow. The cow's x-coordinate and the cow's direction and speed. We're going to call the direction and speed dx for the change in x. So that is how we're going to label the velocity, which is the change in the position. Another difference shows up here in the third image, where I've made a detailed note to myself describing what's going to happen when the cow gets to the edge. So what I'm saying here is that if the cow's center, the cow x, tries to go past width or past 0, then we're going to reset it. So here the decision I'm making is that I'm going to let the cow get all the way up to the edge of the box, but not outside. The Big Bang options are relatively straightforward. There's on tick, to draw, and on key. So now I'm going to jump to the V0 solution, and in all of these solution files you can see a list of kind of where each one is in it. You might choose not to read that so that you don't get too far ahead. What you might want to do now is try to do some of this yourself and then use these solution files to catch yourself up, or watch the video to catch yourself up, or follow along with me either way. So look, here's the constants, and the constants are relatively straightforward. There's the width, the height, the center Y, there's two cow images, and the background. Nothing really new there.